Hello friends. This video is brought to you by mywayteaching.com.
We are now in a position to derive the quadratic formula for finding the roots of quadratic equation. So let us start with the general form of quadratic equation, which is ax square plus bx plus c equal to 0. A cannot be equal to 0. Let us solve this equation by method of completing the square. Divide by a square throughout will give me x square plus b by a times x plus c by a equal to 0. Completing the perfect square, we get 2 into x into b by 2a plus b by 2a whole square minus b by 2a whole square plus c by a equal to 0. First three terms will give us x plus b by 2a whole square minus b square by 4a square plus c by a equal to 0. Further solving, we get 4a square LCM, b square minus 4ac equal to 0, or x plus b by 2a whole square equal to b square minus 4ac by 4a square. Now if b square minus 4ac by 4a square is greater than or equal to 0, then we can find the square root by removing the square here and then find the value of x. But if it is negative, means less than 0, then there won't be any roots. So let us consider the case that if b square minus 4ac is greater than or equal to 0. In that case, x plus b by 2a is equal to under root of b square minus 4ac by 4a square, which is equal to plus minus under root of b square minus 4ac whole by 2a. Solving further, we get x equal to b by 2a plus, that is minus b by 2a, since we are bringing this term to the right side, plus minus under root of b square minus 4ac by 2a. So x can take the values minus b plus minus under root of b square minus 4ac by 2a. So the two roots of the quadratic equation ax square plus bx plus c equal to 0 are minus b plus under root of b square minus 4ac by 2a and x equal to minus b minus under root of b square minus 4ac by 2a if b square minus 4ac is greater than or equal to 0. But if b square minus 4ac is less than 0, then the quadratic equation ax square plus bx plus c equal to 0 does not have real roots. That means then the equation does not have any real number as its roots. Let us read the question. The area of a rectangular plot is 528 meters square. The length of the plot is 1 more than twice its breadth. We need to find the length and breadth of the plot. Let us solve this question by using the quadratic formula. We know that area of a rectangle is length into breadth. So x into 2x plus 1 equal to 528. This gives us the quadratic equation 2x square plus x minus 528 equal to 0. Compare it with ax square plus bx plus c equal to 0. We have a equal to 2, b equal to 1 and c equal to minus 528. Now, before substituting in the quadratic formula, which is x equal to minus b plus minus under root of b square minus 4ac by 2a, we can start by finding b square minus 4ac first and then substitute in the quadratic formula. So let us calculate b square minus 4ac, which is equal to 1 square minus 4 into a's 2 into minus 528. This is equal to 1 plus 8 into 528, which is equal to 4225. Now we can directly find the roots of this equation by substituting in the quadratic formula and get x equal to minus 1 plus minus under root of 4225 by 2 into 2. Solving further, we find that 4225 is the square root of 65. So we have minus 1 plus minus 65 by 4, x equal to minus 1 plus 65 by 4, that is 64 by 4, or x equal to minus 1 minus 65 by 4, that is minus 66 by 4. Now since x is the breadth of this rectangle, so breadth cannot be negative, we will say that x equal to 64 by 4, which comes out to be 16, is the breadth of the plot, and then we can calculate the length by substituting in 2x plus 1. Since x cannot be negative, being the dimension of the plot, so x equal to 16 meters is the breadth of the plot, and the length of the plot will be 2 into x plus 1, which is equal to 33 meters. Let us read the question. Find two consecutive odd positive integers, sum of whose squares is 290. We know that if one of the odd positive integer is say 3, then the consecutive positive odd integer will be 5. That is 3 plus 2 will give me the next consecutive positive odd integer. So we start by assuming let the smaller of the two consecutive positive odd integer be x and the second will be x plus 2. It is given that the sum of whose squares is 290, that is x square plus x plus 2 whole square is 290. Let us solve this and get the quadratic equation, which comes out to be 2x square plus 4x minus 286 equal to 0. We can take out 2 common and find the equivalent equation, which will be x square plus 2x minus 143 equal to 0. So now the roots of this equation will be same as this one. Comparing this with ax square plus bx plus c equal to 0, we have a equal to 1, b equal to 2 and c equal to minus 143. Now using the quadratic formula, substitute and find the value of x. Substitute in this formula, we get, which gives x equal to minus 2 plus minus under root of 576 by 2. We find that square root of 576 is 24. So now our x is x equal to minus 2 plus 24 by 2, or x equal to minus 2 minus 24 by 2. And finally, on solving we get x equal to 22 by 2, or x equal to minus 26 by 2. But x is supposed to be a positive odd integer, so x cannot be equal to minus 26 by 2, implying that x equal to 11, and therefore the other consecutive odd integer will be x plus 2, that is 11 plus 2 equal to 13. Let us check whether the two consecutive odd integers satisfy the condition that sum of their square is 290. We find 11 square plus 13 square, which is equal to 121 plus 169, which is equal to 290. Hence we have checked and found that x equal to 11 and 13 are the required consecutive odd positive integers.